All right, gang, here we go. This is Chem 1, Unit 12, Part 4. We're talking about acid-base theories. Okay, specifically, we're going to talk about Lewis acid-base theory, or Lewis acid bases. And so this is going to be a really short video. All right, now, last video, we talked about Bronsted-Lowry acids and bases, and we talked about all about how to follow the hydrogen from one anion, how it changes as it gets transferred from one to the other, and how Bronsted-Lowry established that acids and bases were proton donors or proton acceptors. The same year, and it's pretty interesting, like 1923 was the year of acids and bases. So that same year, Bronsted-Lowry developed their theory. Gilbert Lewis came up with his theory for acids and bases. Yes, this is the same Lewis as the Lewis dot structures, and he came up with his theory. Now, his theory is arguably more robust because everything that's a Bronsted-Lowry acid and base is also a Lewis acid and base. However, not everything that's a Lewis acid and base is a Bronsted-Lowry acid and base. The big problem is with the Lewis theory. Okay, and it's not really a problem, but the big hindrance of the Lewis theory is that in order to establish which one's the acid, which one's the base, is you have to follow electrons. Electrons are notoriously harder to follow than protons, right? Because with a proton, you can just see, well, oh, the H was there, now it's over here. Whereas when we write out a chemical equation, most of the time we're not writing out the electrons, okay? And so with his theory, a lot of times this kind of goes by the wayside in general chemistry courses because it's just harder to follow those electrons, and it doesn't really get you anything when compared to running with the Bronsted-Lowry acids and bases. And so for the most part, this kind of just goes by the wayside until you get to organic chemistry, when you really have to start following the electrons. And then once you start following the electrons, and you start looking at some acid-base reactions, the Lewis theory becomes by far and away more useful. All right, but so for now, we're just kind of gloss over it. Just generally, what is it about? How do we use it? Kind of thing. It should be a really short video, and then from then on, we'll just kind of ignore it, except for the couple questions you have on it on a quiz and then the exam. All right. So in the Lewis theory, an acid is an electron pair acceptor. Okay, and then a base is an electron pair donor. Now, don't get this confused with Bronsted-Lowry. Remember, Bronsted-Lowry, an acid was a proton. Okay, proton donor. Okay, and then the base was the proton acceptor. All right, and so these can be kind of confusing to pay attention to, because the acceptors have switched, but we're changing the charge on the thing that's being changed. That's kind of how I remember it. So anyway, so an acid is the electron pair acceptor, and then the base is the electron pair donor. Now, sometimes in all Bronsted-Lowry acids and bases, that's exactly what's going on. We're just looking at it with the opposite charge. Okay. Now, the thing that makes it interesting with a Lewis acid and base is most of the time we're forming a new bond. Okay. And so here you've got ammonia and then boron trifluoride here. And so the ammonia has a spare lone pair, but the boron does not. And so the Lewis base of ammonia is going to donate this electron to the boron here. Okay, and then the boron is going to accept it, and so we actually get this new bond that forms right here. Okay, and so this is an example of a Lewis acid base. Notice that it makes one molecule. Now, all of those acid-base molecules that you practice with Bronsted-Lowry are still really Lewis acids and bases. However, this is obviously not a Lewis acid-base reaction, although it does follow, it has many of the same properties as an acid base. Okay. So here, let's analyze this guy together. So you got a fluorine, you got boron trifluoride again. Notice performing a new bond, so we're just making one of these guys. And so obviously we know that boron only made 3 bonds here. There's no lone pair right here. And so this lone pair is going to get donated over here. Okay, and so that means our fluoride ion is our Lewis base because it's donating the electron pair. And so then the Lewis acid would have to be the BF3. Okay. All right, so this is our base, and this would be our acid. All right, and that's it for Lewis acid and bases. I told you it'd be a short one. All you had to do was hang on there for a couple minutes. So anyway, we're starting to get into the fun stuff of chemistry. We're just around the corner from titrations, one of the funnest things you'll ever do in high school chemistry. So anyway, hang on to your shorts, do your practice problems, and let me know if you have any questions, and I'll see you on the flip side.